Thank you very much. As I was commenting earlier, I really don't have any skin in this game. I'm just sort of here as an outside auditor, if you will, to audit the world's power flow books. And the keepers of the books, I will contend, have been royally cooking the books. So, okay, what I assert is that climate change is a myth, promoted by a total scam, a dishonest scam. The IPCC and its collaborators have been originally tasked to use computer modeling, observational data from satellites, ocean bathymetry, global surface radiation monitoring network to determine some very important parameters for the Earth's climate. The so-called power imbalance, the global average temperature history, the power balance feeds back stability strength, and actually that's unfortunately depends on the next one, determine what are the dominant processes that are controlling the climate. In my opinion, they have grossly botched all of these efforts. Prejudicially, erroneously, and dishonestly claimed that there is global warming, in turn leading to a climate change crisis. As a result, their whole argument leads to what they forebode as an impending climate catastrophe. I show here in this talk that those claims are bogus. Instead, there's a very powerful natural feedback system that stabilizes the Earth's temperature. That's independent of greenhouse gases. Okay, first off, let's look at how their argument goes. I believe it's a house of cards. Based on their claims of an observed power imbalance and an associated global warming, the IPCC and its collaborators and contributors assemble a flawed house of cards that forebodes this climate change. They just honestly claim to have observed a net power imbalance in the Earth's radiation budget. Then they argue that this leads to global warming, and if proven, that leads to climate change. Climate change, in turn, is where all the bad stuff happens. It leads to an increased frequency of extreme weather events and other bad stuff. The extreme weather events leads to a global apocalypse and climate change. NOAA, the National Oceanographic and Atmospheric Association, dishonestly claims to have actually observed this increased frequency of extreme weather events. Okay, they claim there's a the group claims there is a net warming power imbalance of 0.6 plus or minus 0.2 watts per square meters, and it is claimed that is due to a buildup of atmospheric greenhouse gases. And by the addition of only 2 watts of what they call radiative forcing to this power imbalance, 2 watts per square meter squared. And the net result is they demand trillions of dollars to fix it. Okay, I assert this whole house of cards has collapsed. They have not observed a net power imbalance. They have not proven global warming. And NOAA has not observed an increased frequency of extreme weather events, and I'll show that from their own data. Without a power imbalance, there's no climate change crisis, and the whole house of cards collapses. Okay, and you no longer are on the hook for trillions of dollars. Okay. Okay, based on what I'm saying here on the following observations. Their computer modeling uses very seriously flawed physics. It's incapable of simulating global warming. It's capable of simulating temperature history and or the albedo history, let alone predict the future. The CMIP-5 simulation is actually a result of many laboratories running, I don't know if it's the same code or independent codes around the world, and there's a total lack of consensus among all of these predictions. That's why they have to have this. Basically, the CMIP-5 is a vote of, well, we're just going to average the polling that we've done. Totally silly way of doing science. Okay, and what I will show you is that the observed power balance data are fully consistent with zero power imbalance. And I'll show you exactly where they have fudged the data and cooked the books, if you will. Okay, the way they do it is through what wrong button, okay. What I refer to as the Hansen, Loeb, Stevens, Wild, bad penny. It's like the proverbial bad penny. It keeps showing up over and over and over again. It's being stuffed in there where it doesn't belong. This is cheating where they cook the books. I'll also show you that NOAA's claims from their own data showed no increase in extreme weather events. And I will finally show you that there is a naturally occurring feedback mechanism that saves us all. Okay, now the first picture I got was sent to me by Willie Soon. This shows you where the weather stations are, and the second one is actually by Wild et al. In his 2015 power balance study. And these show you where the data, the actual weather data are collected. You'll notice that they're all on the land. But 71% of the world is ocean. Ocean is where all the action is. Only 29% is land. Okay, and it really got bad that when Wild had to do the 2015, they only had 6 stations to cover the whole ocean, and they were all in plus or minus 9 degrees latitude of the equator, and one of them was in the mouth on a lighthouse in the mouth of Chesapeake Bay. Hardly open ocean. Okay. Another thing that they do that is a cheat is they only report anomalies. Okay, it's a sneaky way of hiding how you're cheating. There's no reference value from where 0 is. It's an anomaly relative to what? They never tell you. They never give you that reference. As a result, the value, you have no idea what temperature did they actually claim to have measured. And you can't use the Stefan-Boltzmann law to calculate this radiation. You don't have the faintest idea. So it's really kind of totally useless. Okay. Another one, this was Jonathan last night talked about this. There are difficulties in measuring temperature or even defining it, as twice, but the IPCC, most importantly, Hansen, Loeb, and Stevens all agreed, okay, here's what we're going to do. And so if they agree, then that's the IPCC's decision, effectively. So they decided that rather than go for the effect, let's go for the cause. I agree with them. This is much easier to measure, is to measure the global power balance. Okay, what is a global power imbalance? It's more energy coming in from the sun in the form of sunlight than there is energy leaving the Earth in the form of reflected sunlight or just radiant heat. Okay, it's a little piece of jargon that you keep running into. They like to be pedantic and call sunlight shortwave radiation and the far infrared long-wave radiation. Okay, so how does this work? Well, it's really simple, just conservation of energy, or Gauss's mathematics law. If you have more power coming in than leaving, you have a buildup of power. Pretty straightforward. And so ideally, you should be able to observe this all just from satellite radiometry data. They do this using power flow diagrams. Willie soon showed you one of these. I'll show you a whole bunch. Okay, this one is from the IPCC's 6th assessment report, 2021. Okay, and here they show, this is the all sky, the whole world, and there are 4 important numbers on here. Okay, here's the power coming in, 340 watts. These are numbers that you should be able to remember. Here's the power going out, 100 watts. Here's the thermal heat being radiated. Okay, so this minus that should give you the power imbalance, and that's this number that's down here. One assumes these numbers are all from observed satellite data. That's a very bad assumption. They aren't. So the accountant slips in some sneaky entries there. A lot of them are coming from the CMIP-5 simulations. Okay, you'll notice I had 2 diagrams there. There was the left-hand diagram was called all sky. The right-hand diagram was called clear sky. It represents the power flow on the portion of the Earth where there are no clouds, where it's totally cloud-free. And the all-sky diagram, actually there should be 3. There should be the cloudy sky diagram, and so that the all-sky is the area-weighted average of the clear and cloudy. Okay, now this separation was defined very early by a gentleman named Ramanathan in 1987, and he decided that it was much easier to analyze if you could divide the sky into 2 quasi-homogeneous sections, all with which would have the same albedo, to make everything easier to calculate. So he established this condition, this convention of using clear and cloudy sky, and it's stuck. But I will go into this a little bit here. He did this following some very early, the very first data came in from the Iribi satellite, and he only had a partial analysis of only 4 months around the calendar. And so he expected that he had realized that this was all totally preliminary. Subsequent satellite projects would simply and much more accurately fill in the data, and that this power balance could be measured and calculated. Then, unfortunately, that never happened. The funding for all of this never occurred. That's what happens when you're doing experimental science. You learn very quickly, here's how much I need. Sorry, here's how much you're going to get. Okay. Then a very important and totally ignored paper came out by King et al. In 2013. This is crucially important. And he discovered not 2, but 4 quasi-homogeneous regimes that really must be discovered. And he did this with a very careful observation of 13 years worth of Terra and Aqua satellite data. Now, independently, Wild et al. In 2015 tried to decide, let's see what happens if we try to use land and ocean partitioning. And so they built a power flow diagram, and it is totally ridiculous. And the fudges just become totally ludicrous. I will show you those. And so finally, then, Wild et al. In 2019 reverted and redid all the work to use Ramanathan's clear sky, cloudy sky partitioning. And that was finally used in the adopted by the IPCC 6th assessment report in 2021. Okay, I will show you that it's very straightforward using the same methods to build a fully self-consistent power flow diagram. The important thing is you need to kind of pay attention to where these processes are occurring altitude-wise. And I will show you that ignoring King's discovery was a very, very bad mistake. Okay. These were vitally important, and they never got referenced. Okay. Here is their crucial figure. Okay. Here, they're plotting vertically the cloud fraction of that area. They divide this into actually 4 partitions. There's for the ocean, for the land, and each one has a clear and a cloudy component. Okay, and so they measure what is the fraction of the Earth that's covered by clouds. Okay, and they find. Unfortunately, they only could do this in the daytime, so they don't have nighttime reports. Okay. It shows the land and ocean exhibit very, very different temper, and these are oscillating in time annually. Okay, and importantly, you'll notice, the solid line is Terra, and dashed lines is Aqua, and you'll notice, and they're sun synchronous. They pass over the equator 3 hours apart, and so there's a consistent difference just in the 3-hour passage of the cloud fraction, both on the ocean, and it's in the opposite direction, so it's not a calibration error, it's in the opposite direction on the land. Okay, so you have these 4 different areas. Each one has a different, dramatically different albedo. Albedo is just simply a pedantic word meaning the total reflectivity of sunlight. Okay. Now you'll notice these are all very different. Just combining any pair of them, as Ramanathan did, creates very inhomogeneous because ocean and land are clearly very different. Okay. The average over land is 55%. The average over ocean is 72% cloudy. And the combined average is about 67%. Now, you can just simply multiply, if you work out what the albedo is, and then multiply by the incoming sunlight fraction, and you can get how much reflected sunlight is there. Okay, I did that and created these, the scale here. So I calculate that just from their data that you see, just for the average, you're seeing about 5 watts oscillation in the total reflected sunlight. And worse, if you have clouds moving from land to ocean, like for example the whole Pacific West Coast of North America, there's a 23 watt per square. These are huge numbers. Remember, the imbalance was 0.6 that they claimed. Okay. Okay. So these are the oscillations. Okay. Okay. Stevens et al. In 2015 observed a very similar, and Willie showed you that graph yesterday. I'll repeat it, show you here later. It is shows a non-sinusoidal annual systematic oscillation, and actually Stevens 2015 was also ignored by the IPCC, and Stevens never associated that oscillation with King's observation of the cloud fraction, but it's very clear they track. Okay. Okay, so what that says is that the cloud fraction very strongly modulates the total outgoing power flow by changing continuously the albedo. Both King and Stevens observed that. So that clearly is determining the heat balance between, and this oscillation varies between summer and winter. And so I claim that this is very strong support for my cloud feedback model. Okay, there are a lot of new questions that this work presents that are presumably the data are still available and can be analyzed. Why is it the oscillation bigger in the land than it is in the ocean? None of these things are known. Okay, let's move on to discuss the computer modeling. I believe most of the computer models are all the same code written by GIS. I don't really know that for sure. But the total disarray of the results was first noticed by Steve Koonin in a very important book that he wrote recently, Unsettled, What Climate Science Tells Us, What It Doesn't, and Why It Matters. He was the White House science advisor for President Obama. Okay, and also a very recent New York Times article authored by Gavin Schmidt, director of this. I subscribed to New York Times, so I got it. Okay, we study climate change. We can't explain what we're seeing. He's admitting that his models don't work in the title of his article. Okay, the CMIP5, I'll show you how violent. Okay, okay, they are totally incapable of describing the history, let alone both the temperature anomaly or the Earth's albedo. And they can't possibly attempt to and totally fail describing this oscillation. Okay, this paper graph from the 5th assessment report made it to the American Physical Society news back page. And this shows you, I think, more than 40 odd simulations from the various CMIP5 models. Okay, this is again, well, you heard what I my feelings about presenting anomaly. Okay, this is the black curve is what's actually happened. That's history. They can't even explain, the gray curves here are the simulations. They can't even simulate the history. Not one is capable of simulating. And this major disagreement between theory and observation indicates something's very, very wrong with the physics that's in the model. So if you can't explain the past, there's no way you can reliably predict the future. Okay, and this, the same thing is true with their attempts to simulate the Earth's albedo. That's the reflectivity. Okay, this is the pictures that from Stevens at 2015, where again I have added a power scale onto it, and you can see their oscillation is about 9 watts. This is the CERS data. They somehow are analyzing the satellite's data differently from what I did. There's a factor of almost 2 difference. I don't understand that. That needs to be looked at. But okay, so the black curve is what's been measured, and this is a 10-year average of the albedo as measured by the CERS, Terra and Aqua satellites. And and the black curve agrees very closely with what at least the eyeball average of what King did. Okay, they attempted to simulate this, and these are all these colored curves. They're wrong by about 10 watts per square meter. All right, and they claim that, and this one was also hidden. It never made it into, for the Stevens, never made it into the 6th assessment report. Okay, so it shows you 10 watts in the oscillations, and comparable to the error in the simulation. Despite this, they say, oh, our simulations are terribly accurate. We can do it to better than 0.7 watts per square meter. Okay, now one of the things that they don't point out, but finally Stevens admits, is that the sunlight itself is also changing. The Earth is not in a perfectly circular orbit. It's elliptic, and so given the 1 over r squared effect of sunlight, the total sunlight varies by about 22 watts just from the orbiting the Earth. Okay, this is also from Stevens et al. 2015, and it shows this sinusoidal oscillation of the sunlight, and also the various wiggles from the clear sky and cloudy sky fluxes. Okay, the total. Now, if you add this to my power scales, this shows you that the sunlight, due to this oscillation, is changing by about 31 watts per square meter square, because you have to add on. This is roughly comparable to the oscillation. Okay, and you'll notice their simulation can't even get the phase of the oscillation correct. Okay, I mentioned this earlier. There's a okay, so you move on now to the actual data, and here's where I put on my auditor's hat. None of the data reported by the IPCC and its contributors actually show a net warming power imbalance. There have been a variety of input data that have been taken. There are these satellite Nimbus, series of satellites, Terra and Aqua, the most important ones. Ocean heat content. There's a whole buoy chain that was supposed to have buoys every kilometer. Never made it. I guess it's too much of a hazard in navigation or something. And there's the baseline surface with radiation network of ground stations. All of the various values measured between these various modalities for measurement are all in violent disagreement with each other. And this is what you were talking about. It's the Shannon sampling theorem, which tells you how frequently you got to sample. They're nowhere near sufficient to. Okay. And so what do? They fabricate data to fill in the gaps. Mentioned Lyman and Johnson. They even published papers about how they did it. Okay, but if your schedule says, and you're being paid to write a report, you write a report, whether or not you got the data or not. Okay, what do? They just totally fudged. And they fudged in the matter that they were told to, apparently. This honestly shows what best they could see is no warming. They change it by adjusting the data to show that it is warming. And Willie Soon last year told me that he's observed this same kind of fudging in all the temperature data. Okay, it should be simple. Remember, as I showed you, we had these three numbers. You'd measure power in, you measure power out, and subtract. Unfortunately, experimental data collection is not that easy. Not as easy, especially if you don't have enough money to do it. Okay, so power in is the sunlight. Okay, even though it's oscillating, they want to insist on doing the annual average. Power out, okay, that's about 340 watts. Okay, the sunlight reflected is about 100, and the radiated heat is about 240. Simple enough. Well, it's not that simple. Okay, these are big numbers. And the difference between them is very small. Only about 0.2% of the big numbers. So that's what you're trying to measure by doing this subtraction. Unfortunately, an error in any one, an uncertainty in any one of these numbers reflects in the final summation. Okay, and many of the observers, in fact the important ones, Hansen, Stevens, Loeb, Lecoyer, all admit up front, I'll give you a quote later on, that the satellite radiometry data and ocean heat content data methods are incapable of determining the Earth's power balance to the needed accuracy. Okay, so what are the numbers you need? The three that I mentioned there on the top line of the power balance. And to be consistent, you want to do all of these at the same altitude. And that convention is shown as the so-called top of the atmosphere. They never actually define exactly where that is. But then, when they didn't have enough data, Hansen suggested, well, what we can do, this is kind of a cumbersome restriction. Let's kind of ignore it and mix up measurements made at different altitudes. So if you naively assume the numbers represent actual observations, you're wrong. If you carefully read the text, you find out what they did. A lot of them, they just stuff in from the CMIP5 calculations. Okay, who knows who did it? Whether it's the lead author, some politician, something, I don't really know. The net result is that the power balance numbers end up very badly fudged. And I will show you exactly where. Okay, what's the arithmetic look like? Okay, we have these 340 minus 100 minus 240, and that's the difference you're seeking. Okay, they all have uncertainties here, typically mentioned as sigma. The standard method is that the resulting uncertainty is the RMS sum of all of the individual uncertainties. That's the way we do science properly. Okay, and it gives you an immediate cross-check just by staring at it, is that any one of them, the sum has to be bigger than any of the individual components. And so then you look, well, if the imbalance is greater than the uncertainty, then we'll call it global warming. If not, it's no global warming. Okay, here, as I mentioned now, they admit, and this is Loeb himself, a limitation of the satellite data is their inability to provide absolute measure of the net top of atmosphere radiation imbalance to the required accuracy level. That's a direct quote. But nonetheless, you had to do it. Okay, so they adjust the numbers. They add in switch altitudes. They mix them all up. And what they do is they stuff in what apparently, according to Willie, this goes clear back to 1985 or 87. What Hansen originally he proposed, the one I saw him was 0.58, and I think I also seen 0.85, but all in this range, and it was terribly small error bars. Okay, here are the reports I'm going to. I hope you can read the small numbers. Sorry about that. I just got these are a lot of different reports here. Stevens et al. Going through. Here's various Stevens reports. Vild et al. 2819 and the IPCC reports. The red numbers are these are the numbers that they stuff in. Anything with a star on it, that's the fudged bad penny. It keeps showing up over and over, and the actual sums are in this column, which are very different. You can just do the arithmetic yourself, and they don't add. Let's go through a few of them. Okay, here are the earliest ones, Stevens et al. 1981, and Ramanathan, early study 87. They were pretty cautious at this point, admitting they didn't have it, but they weren't under any pressure. And both the data are fully consistent with no power imbalance. Here's Ramanathan's very first power flow diagram. Here are his numbers. He had 237 going out, 343 coming in, 106 reflected. Okay, and he's the guy who did this original partitioning that I mentioned earlier. Okay, Loeb et al. In 2009, 2012, they were at the suggestion by Hansen, suggested we adjust these numbers, and he's the one who said this limitation of satellite data is their inability to provide absolute measure of the radiation imbalance. Okay, so he adjusts the numbers, mostly of the Uribe and the Nimbus satellites, and to show a global warming power imbalance. Okay, so he's adding in the Argo buoy chain data, various other. Okay, and he gets amazingly. This was actually forced on him in various papers by Hansen. Okay, so Loeb, these are his results. Okay, this is his 2009. Here's the satellite in 2009. They're very small. Here's and he has a list of the paper, a whole bunch of numbers. But here he stopped the beginning of what I call the bad penny. 0.6 plus or minus 0.1. Okay. Then, this is a very important paper. Willie showed this one yesterday. This is by Stevens et al., 2012. This got used for the IPCC's fifth assessment report. Okay, Loeb et al. And Stevens et al. Kind of joined forces to both admitting that you can't do it just by satellites alone, and they were going to mix up the satellite and ocean heat content data, and to get a sum, the actual sum is 0.5 plus or minus 3.9. No warming at all. But what do they report? 0.6 plus or minus 0.4. Where'd that number come from? Okay, this is the diagram. Actually, they had two diagrams, or three, that were, Willie showed you this one yesterday, and they've got that number right here and here, just to be sure that you see it. And they also show you what the CMIP5 simulation says it's supposed to be. Okay. So this got used by AR5, and they admit that they have adjusted or fudged the numbers. They admit that they use visibly incorrect numbers. They do not say how they calculated that fudged number. They just said, well, we kind of like the error bar from that better. And they very clearly fail that immediate cross-check. Okay, they slightly increased Loeb's earlier numbers from plus error limits of plus or minus 0.1 to plus or minus 0.4, but kept the same value. LeCouillier, who was one of Stevens' co-authors, Loeb's co-authors, apparently this was, he was a little annoyed with this fudging, and so he set out to produce a minority report, if you will. He couldn't handle this kind of shady operation, dodgy operation, so he reanalyzes the ocean heat content data, okay, and he has two different values. He has to make some adjustments, but he calls these constrained and unconstrained, and admits how he does it, and he comes up with zero power imbalance. Okay, and here is his power flow diagram. Okay. Again, the three numbers on the top line. Okay. Then along come some important whistleblowers. Trenberth and Sulo, and get a third author later on. Okay, okay. Satellites are measuring the top of the atmosphere radiation. And the heat content is at the surface, a very different altitude. Okay, you can only mix up these numbers legitimately if you know what's going on in between. They don't. Okay, so Trenberth et al. Are highly critical of Loeb, Stevens, LeCouillier, and the claims that they do understand it. Okay, and they've given this understanding the name closure, and they put that in their titles. And Trenberth and Fasulo point out to a huge difference. This is not a simple error. They asked, where does the energy go? And Hansen responds, oh, it's just a matter of satellite calibration error. Okay. But Trenberth, Fasulo, and Malsmeda years later come back and say, no, it's unresolved. So these guys are the whistleblowers. Here's Trenberth and Fasulo's. Here is this missing energy that here's their question. Where does the energy go? Okay, now we have this debate, and this fudging is starting to get out in the public. So we have an open debate now between Stevens and LeCouillier, where Lecoyer wrote his minority report. And there was also this severe public criticism by Trenberth and Fasulo. So I guess somebody said, you boys need to play nice. So get together and make nice. Okay, so they co-author a very important paper in 2015, which is literally a mea culpa. They admit to having fudged the data. They may admit to having made an unjustified ad hoc choice between OHC, oxygen heat content, and Sarah's data. Those are quotes. Okay. The adjustment they needed to make in order between them were kind of what the order of about 10 watts per square meter. These are the fudges where they're cooking the books. Okay, and so, and their comment in this totally ad hoc fashion, there's no real evidence to support one adjustment over the other. Nonetheless, on the abstract of the line, they come back and say, well, guess what? The power balance is really 0.6 plus or minus 0.4. Okay, here's their power flow diagram. Here are the numbers for the ocean heat content data. Here are the numbers for the satellites. And here are the numbers just grab right off that plot. Here they are, 0 plus or minus 5.6. And here's what they report in the abstract. Okay, now things get really dodgy. The Wild et al. Comes in, and he has a new fudging technique. He reports, for example, okay, normally you'd report 340 plus or minus 0.1 or plus or minus 0.5 for a number. So he says, well, it's 340, parenthesis 340, 341. Okay, you'll notice that these are all rounded off to the nearest whole number, yet when you, and the round off error that you introduce by doing this is 0.5. That's exactly the value that you're looking for when they do the subtraction. Okay, you could be a little bit less dodgy. Legitimately, you could add in the shift that you do as a very real uncertainty. You can also add in the round-off error in the RMS sum. Nobody does that. Okay, now things get even sillier. Wild et al. Decide, well, let's try doing the power balance by ocean and land. Okay, here's, so they set, rather than using Ramanathan's partitioning, they have sea only and land only separate power balance diagrams. And for sea only, they even put in a power imbalance. Look at these two numbers right here. Something's noticeably dodgy here. Here are those numbers again. 347 amount of sunlight that happens to fall on the ocean at the top of the atmosphere, 325 on the land. How do the sunlight photons know, oh, I'm headed for the ocean, I better move over to the ocean? Okay, they again, you calculate the RMS sum of these ranges, you get 7. They report 0.8 plus the range is that the RMS range that they calculate is 0.8. And so and they even realize that they fudged these. And apparently the way they do it is they just keep adjusting input numbers until they get the desired output. And this is a direct quote from Wild et al. As noted above and evidence from figure 2, the surface downward fluxes averaged over land and oceans are nearly identical, which seems a robust feature in various estimates. This is the case despite an insulation at the top of the atmosphere, which is higher by 22 watts over ocean and over land. These guys believe their own bullshit. I'm sorry. Okay, but that's all right. When you average them together, guess what? You get, you calculate it to 1, which they round to 0.6 plus or minus 0.2. Okay. This is the bad penny again. Okay, so that didn't work so well. So then they get tasked to do, well, let's do something for the AR, the Wild et al. 2019. 4 years later, okay, say you revert to Ramanathan's clear and cloudy sky partitions, and they're getting data from the baseline surface radiation, which is now supposed to report. They have a few more stations, nowhere near enough from the ocean. Okay, and here they need to find a new place to fudge, and they find there's a 33 watt reflected power. They just don't know how to do it in the clear sky diagram, so they just pull it off the CMIP5 calculation, and that has been adjusted to give you the bad penny. Okay, so here is their 2019. Here are their numbers. Here's their power imbalance down here, and here is their fudged important number. There's 33 watts here that they just pull out of the CMIP 5 calculation, and so here are their numbers. Okay, using the normal notation, plus or minus, or using this dodgy notation that they use. These are the RMS sums that you calculate. Okay, and what do they report? Plus or 0.6 plus or minus 0.4. Where'd that come from? Okay, and the RMS error range is not 5.9. It's just somehow got reduced down to 0.8. Okay, so they submit all this to IPCC for the 6th assessment report. It's almost identical diagram, except the IPCC said, well, we don't show enough imbalance. So they changed a few of the numbers here. There's not much difference between the 2019 Wild et al. Okay, but here are their new numbers. And so they say, well, it's actually not 0.6, it's 0.7. But they reduced the error bars here, 0.2. If you actually do the sum of their error ranges, it shows no warming at all. And their RMS error ranges get dropped by a factor of 10. Okay. It is possible, by the way. How's my time doing?
You have about 11 minutes.
Oh, okay. I'll have to start rushing through some of this. Okay. It is possible to do this quite accurately if you're allowed to just pick your albedos to do a fully self-consistent zero power imbalance 4-component diagram. Okay, you need to pay attention to where all of the stuff is coming from, and you need to get the proper altitudes. There's a 73 watts absorption by the ozone layer. All of this is up in the stratosphere. There's this 10 watts or 20 watts per square meter of the blue sky Rayleigh scatter. They never even seem to pay attention to that, but it gets included in the radiometry data. Okay, and that's all up here in the stratosphere, and the clouds are all down here in the troposphere. And so it matters where you calculate the albedos. Do you calculate them at the top of the atmosphere or at the top of the troposphere? Okay. So what are the three most important processes? Those ones I mentioned. Okay, and the green numbers I use are all what we all seem to agree upon. Okay, what's left over at the top of the troposphere is about 247. Subtracting the ozone and the 20 watts. Okay, this comes from Wikipedia's diagram. They don't say where they're calculating the albedo. Is it top of the atmosphere? I'm assuming that it's top of the atmosphere. So you can recalculate that to the top of the troposphere because of the differences of the components. Okay, and here, pardon the terrible hand-drawn diagrams, but here the square Earth here, there's a considerable latitude you have for adjusting the various albedos, and you still get zero power imbalance. Okay. Now let me mention that I mentioned that which describe how NOAA did its fudging. Okay. They produced by wrote in a paper, 2012, by Jane Lubchenco and Thomas Karl. These are not scientists. Jane Lubchenco is an undersecretary for the Oceans and Atmosphere at the Department of Commerce. Thomas Karl is the director of the NOAA's program. Somehow they got Physics Today to accept this article in 2012. That asserts that there is this increased frequency of extreme weather events, and it has been observed. And if these guys can't get the very best data available from NOAA, I don't know who can. Okay, so they produce an index describing the number of extreme weather events. It's some weighted, some includes hot spells, cold spells, droughts, floods, landfalling, hurricanes. They leave out EF3 plus tornadoes because actually those are decreasing. That would bias it against them. Okay, and they claim just by staring at it, you can see it's obviously grown steadily over the 3 decades. That was right in the subtitle. And here's the data they present. Here is that their index. And so nobody ever uses bar graphs in science. They use point plots. So I just simply traced that diagram onto a piece of transparency twice. And then I flipped it 180 degrees so that the arrow of time is now increasing to the left. Relabel them. And your job is to can you tell which way time is going? Is it obvious that in the last 3 decades there's an alarming increase in the frequency? This is kind of an old trick that Towns and Alvarez taught me at Cal. Okay, it is very clear. If you can't tell, it's easy to see that they're mirror images. But if you can't tell which way time is going, it's hard to claim legitimately that you have an increased frequency. Okay, a few more little details. Clouds, for my model, clouds cast very dark shadows. You can see them just looking down from a hillside or landing in an airplane. Okay, and here is from Harper and Mingarden. Okay, they just have a radiometer. I first saw this on my sailboat with a solar panel output. Notice these are the fluctuations on a cloudy day in Munich. Okay, so it's a huge shadowing effect. Okay, so another important issue that I need for my model. What does sunlight actually do when it reaches surface of the Earth? So 71%, remember, is ocean. So that's really kind of all you need to know of the 71%, 160 watts, 114 gets incident on the ocean, that area fraction. Okay. The power flow diagram that I showed earlier indicates that there's 82 watts whose job is initially not to warm the earth, but just simply to evaporate seawater, to make clouds. That's more than half of the power coming into the earth, and it's about 72% of all the energy absorbed by the ocean goes into making clouds. This is clearly the dominant process of what sunlight's doing in the earth. Okay, so this is a big number. Remember, the IPCC was obsessing with little numbers like 0.7 watts, and 2 watts is the amount you get from CO2. Okay, so but they're ignoring other big numbers like the 70 watts reflected by clouds, just changing from land to earth. 23 watts anyway, a whole bunch of all these are huge, and the big one is just the amount from shadowing. Okay, so let me. Hopefully, I have time to get through some of this. Okay, I assert that it's this evaporation of seawater making clouds, and the clouds that make a natural forming thermostat. Okay, it gains its enormous strength from the fact that the modulation by clouds is huge. It's a very powerful furnace. It's being turned on and off. Okay, and it's so big, it's going to work no matter what the small heat leaks there are from CO2 or the like. Okay, it works just like any thermostat in your home. Okay, the furnace, the clouds, shadows are essentially turning off the furnace. No shadows, they turn the furnace on. And they modulate the production. The clouds modulate their own production rate. Okay, so and what is very clear that this is not a totally random process. It seems like clouds are sort of random, but so it works the same way the thermostat in your house works. Okay, the clouds produce these huge shadows. Okay, so when the cloud cover is too high, the furnace gets turned off. Okay, the sea surface temperature then becomes too low because there's too much shadowing. It's colder in the shadows. Okay, that it turns off the evaporation of seawater, but we had too high clouds, so the clouds that are up there very quickly dissipate by evaporation, precipitation, and the like. And the temperature increases and equilibrium is restored. And the reverse process occurs if they're too low. Okay, I assert this is the dominant mechanism because these are where the big numbers are. Okay, so the last task was to calculate what is the strength of the feedback stability. Okay, obviously the Earth had a very stable atmosphere for a very, very long time. Question is, why is that? Unfortunately, the IPCC's misidentification of the dominant mechanism had them botch their task. Let me show you. Okay, so the original work for measuring this was a National Academy, U.S. National Academy report, understanding climate feedbacks, and then Sherwood et al. In 2020 published kind of with a definitive report on all this. I'll use Sherwood's mechanism. This got calculus in it, so for the calculus challenge, I'll flip over it. And the net result, you could just pull the numbers off and calculate what the feedback. The important parameter that's missing is What is the change in clouds due to the change in surface temperature? That's straightforward to look at. The evaporation rate of water is a very rapid function of surface temperature. So just turning the sunlight on and off dramatically switches on and off the evaporation of water. Okay, and here is their diagram. I've extended it. So if you use my feedback, the total feedback is about 7 times bigger than what they assume. Okay, so let me just quickly go through the conclusions. Great news. The planet is not in peril. There's no climate crisis. The bad news. The IPCC claims are a total hoax. Trillions of dollars are being wasted. I claim IPCC has not observed a power imbalance. All the observations indicate zero observed increased power imbalance and zero increased frequency of extreme weather events. So the house of cards has collapsed. The requested trillions of dollars are unnecessary. So my additional conclusions: computer modeling clearly has bad physics in it. All the models are in disagreement. Here's another important observation. You've heard the IPCC, or especially Al Gore, claiming that all climate scientists are in agreement with each other. There is great consensus. The fact that all of these models give you different results proves exactly the opposite. Also, the fact that we had this big squabble between Hansen, Stevens, LeCoyer, Trenberth shows we do not have consensus. But the conclusions are, when you audit their books, you see they have cooked the books. They have dishonestly fudged, and it's so happens that I just give it the name, the Hansen, Loeb, Stevens, Wild, bad penny, that it keeps shoring up. And they use bad arithmetic and fudged data. Okay, okay. The other observation I made is that Ramanathan's partitioning of the sky is insufficient. You really need 4 areas. Okay, and you can do it. The King's discovery was very important. The agreement shows that the clouds do modulate. Okay. Finally, I show that there's this naturally occurring feedback mechanism that totally stabilizes the Earth's climate. It's by far the strongest feedback mechanism ever noticed. Sorry I overstepped my time.
Pretty close.
Thank you.
Pretty close. See that much.
Good.
Thank you.
Thank you.